Hi guys, this is Allison from AllyKatkreations. How are you? Please like, share, and subscribe to my channel if you haven't done so already. And if you get anything from my work, I connect the dot, an epiphany, a mind explosion, a new book to read, a new author to explore. Please consider supporting my work. All the links are at the bottom of the description where you can help me and I can continue doing this. Fresh off the mold. Floral business card holders. I didn't think this was gonna come out well, and it did, sort of. Still have some flowery stuff to deal with. Skulls, lots of gems and organite materials in them. Pyramids, hearts, paintings, oils, signs, all kinds of fun stuff. Check out my website, AllyKatzkreations211.com, where you can see my portfolio. Added a lot of stuff last night. Make sure you check out all the tabs because I have a lot of things there. And yeah, if you're interested, please email me. I do everything through private means for the moment. Quantum AI and metaphysical ponderings. Yeah, why not? Just why not? Um, I had a very long day. I'm exhausted. It's getting defeating. Very defeating. So just winging it, looking for new jobs, not having luck. But if anybody knows of remote work and anything that could help me out, let me know. The first article, popularmechanics.com, brand new, second 2D state of matter could propel physics forward. 2D. Scientists see quantum shifting potential in the mysterious Bose glass by Darren Off, published September 13th, 2024. Scientists have investigated a new two-dimensional form of matter known as Bose glass, which could help physicists study a concept known as many-body localization. Such a concept could help quantum computers overcome decoherence by storing information more locally and thus not leaking out into the environment. However, there is a lot we don't know about Bose glass, so this quantum computer use case is put the cart before the horse. Indian theoretical Satyendra Nath Bose is well known for his work, and I'm totally butchering his name, by the way, for his work in the 1920s when the field of quantum mechanics was in its infancy. It's why the lesser-known fifth form of matter, Bose-Einstein condensates, honors his achievements. However, there's a new form of two-dimensional matter recently published in the Journal of Nature by scientists at the University of Cambridge that also bears his name, and it's called Bose glass. Bose glass is unique in that the material exhibits glassy properties, but the particles in this phase of matter are also localized, meaning that each particle sort of sticks to itself and doesn't interact with its atomic neighbors. To visualize the idea, the researchers liken this phenomenon to pouring milk in a cup of coffee. Instead of turning into a most excellent paper bag brown color, the two fluids stay forever apart, leaving behind a never-ending swirl of black and white, aka localization. The usual cup of coffee is egogic, a mathematical concept that an outcome can be measured statistically. However, Bose glass is non-egogic, however you say and pronounce that word, meaning it does not forget its history. So all those precise milk pouring details are essential. For instance, simply knowing that the amount of milk poured in is enough to predict the final color of our coffee after stirring. University of Cambridge Ulrich Schneider, the senior author of the study, and said in a press statement, if we want to predict the full structure of white and dark swirls during the stirring, however, it's important to know where the milk was poured in and how the stirring is done precisely. To create this two-dimensional Bose glass, the researchers overlapped laser beams in a non-repeating pattern, similar to Penrose tilling, and ordered like a conventional crystal. Then they filled the structure with ultra-cold atoms. This 2D structure allows physicists to now study Bose glass in a simpler format. A big limitation of large quantum systems is that we can't model them on a computer. Schneider said in a press statement, to accurately describe the system, we have to consider all its particles and all their possible configurations, a number that grows very quickly. However, we now have a real life 2D example, which we can directly study and observe in dynamics and statistics. When this new platform for study, scientists hope that this two-dimensional Bose glass can help search for a many-body localization material that could be particularly useful for quantum computers. It's a long-term aspiration to find a system or material that has many-body localization. J.R. Chun Yu, the first author of the study, said in a press statement, such a material would offer many new possibilities, not only for fundamental studies, but also for building quantum computers, as quantum information stored in such a system should remain more local and not leaked out into its environment, a process called decoherence, a loss of quantum behavior that plagues many current quantum computing platforms. But this scientist stressed that there are many things at much more basically level that they don't understand about Bose glass. So it'll take time to really figure out what their potential uses could be. And that ends that article there. So for all the people out there talking about quantum this and quantum that and quantum, yeah, it doesn't look like my beds are coming anytime soon because they even haven't figured out. And I'm not saying there isn't quantum computing happening or quantum computers, but there's a lot of freaking problems in it that they still haven't tackled. I keep reading all these articles because I find it, as much as there's a lot of words and a lot of lost language that a lot of people don't understand, let's get down to the basics. They're still figuring out how to get quantum computing going on a massive scale. Just like the DVD burner back in the early 2000s, right? Only in one or two companies really got mass production at it. And then all of a sudden, like 2 years later, everybody had one. And then every computer had one. And then it became obsolete, like not long after that. The LimeWire and everybody taking music off the internet. It took a while. This is new territory, just like computing back then. We had computers, they were shit. And then all of a sudden, a boom happened, and more computers are getting upgraded and upgraded and upgraded. So that's with just technology in general. But we're not there yet with quantum. So I find it hard to believe that people have kind of med beds. I find it hard to believe that people have the ability to change frequency in a human being, nonetheless, someone's DNA to heal. I know this technology exists, but it's not on mass scale. And is it outdated? The conundrum that a lot of people don't think about, that I do, at least for me, is if you look at the SSP program and they're talking about all these like fanciful, technologies that extraterrestrials have, that's great. But even that stuff at some point will get outdated. And why this matters, we are shifting in higher frequency. So let's say a medbed from 25 years ago in Project Montauk, which was probably 30 to 40 years ago, um, maybe even 50 years ago, eh, the project itself, doing all these like experiments and things, right? So a human wasn't necessarily upgraded with the etherical DNA that is unfolding in front of us, the 12 strand, the 48 strand DNA patterns. Um, I'm sure we were only 3D based, and we have our DNA, our basic genetic code. As time keeps merging with other timelines and other delineations of time space, we are upgrading into photonic light, homo luminous. We're all upgrading. So would you put yourself in a machine that is just coming out as what we would consider new, but is really outdated because it's technology from back when? It may work for your 3D vehicle form, but if you're shifting and you're on a higher octane of a love and your body's already upgrading, would you put yourself into something that upgrades you, but it's a outdated machine? I wouldn't. I wouldn't. This is showing us, these articles are showing us, whether you understand them or not, that they're not there yet with quantum computing as much as you would like them to be, as much as they proclaim that there is these technologies. I'm sure there is. But at what point do we outdate them? Because look at the progression of an iPhone or an Android phone. It keeps getting more intricate with more memory and more things and upgrades every year. So who's to say within the next 5 years that the quantum computing will hit everybody in the stores and everybody can purchase a quantum computer? We're not there yet, but who knows what's going to happen in 5 years? A lot will happen in the next 5 years. But in the moment of the now, we still have these things going on and they still have a lot of issues. I honestly can perceive what this losing of the locality of quantum states can be. So what do you do with such things? How do you do that in a normal home, let alone a facility where a humongous quantum computer? If anybody could rationalize like how big a server center is where people have stored their servers, like you're buying server space for your, let's say, YouTube Rumble. Do you know how much wiring and machinery is in one of those centers? Mind-boggling. So we need to take in account all these experiments and all these things are in a good way. They're trying to help answer questions and they're discovering new states of things. That's freaking fantastic. Will it be used for the good? I don't know. We got to put the will of intention to have good things come of these things, but bad is also going to occur as well because we're still living in duality. Um, it's just the way it is. So I find this very interesting. like I said, I'm not an Einstein fan, but Bose, indifferent, very indifferent. If we look into the past ones I did of these, I only ask people to use your discernment and judgment when these things do come out, and we don't know when they're going to come out in mass. Okay, governments use these things, but keep in the back of your mind. Yeah, there are a lot of technological advancements that have not hit humanity in full force yet, right? We looked at, I just gave the example with the DVD burner back in the 2000s. We don't know how outdated it might be. New to us, but it might be old to the paradigm. How outdated a lot of this stuff already is. Sorry, I'm back. Um, Before I move forward, anybody in Florida, Georgia, North and South Carolina, I should have said South North, and all the other states that are going to be affected by the hurricane that is currently forming and getting stronger as we speak. My prayers and my bubble of light will go over all over you. My birth family and where I was born will be affected. Uh, they're in Georgia, but no, southwest Georgia. So they're in the line of the path of when it hits. So my prayers are going out to all of you. There was a tornado 2 counties over from my aunt's house, and yeah, just making sure that they're going to be okay. So sorry about that, guys. This next article, after having to punch through everything, this is futurism.com. The Bite. Scientists puzzled by hundreds of little red dots in James Webb images of distant universe. What are they? Before I get into this article, I am not on board with the James Webb or any of the Fugazi, in my estimation and perception, things on outside of space time. That, I mean, and there is a reality where there is no firmament and outer space actually exists. Cool. But in my paradigm, everything's outside of the ice wall, outside of Antarctica. So I don't know in what dimensional density state they are having such technology, if it exists, if it's don't know where outside of the firmament. I don't know. I just perceive things completely obscured to so many other people. So do not mind me. I just as my own personal paradigm perception, I don't necessarily believe that thing even exists. It may exist in a different delineation of time space. That space actually exists. And I'm not saying it doesn't exist. What my hands are going through is space right now. I just there's some fishy shit with it that I'm not a believer in. I mean, NASA backwards is deceiver in Hebrew. So what are they deceiving us on? There's so many things, and I'm not going into any of that because, of course, it's just my estimation, my thoughts, entertainment purposes only. Red Era. Earlier this year, astronomers revealed one of the James Webb Space Telescope's most spectacular, intriguing discoveries yet, and that's saying something. Lying on one of the most ancient regions of the observable universe, they found were hundreds of galaxies that come to be known as the little red dots. These aren't ordinary galaxies, as Smithsonian Institute astrophysicist Fabio Passucci explains in an essay for The Conversation. These compact red structures, which are only about 2% the size of the Milky Way, puzzle astronomers. The issue is that they can determine what they are because observing them through different mediums, each point to them being a different kind of object. Deepening the mystery, the little red dots were only visible for a period of around 1 billion years, about 600 to 800 million years after the Big Bang. Now they are nowhere to be found, and determining exactly what they are will be critical to figuring out where they fit into the evolution of our universe. Mystery of interior. There are two leading hypotheses on the little red dots. One proposes that they're incredibly dense galaxies packed with up to 100 billion stars. That's as many as the Milky Way, despite being just a fraction of the size of our galaxy. To put that into perspective, Passucci says that these would be like packing the population of China into a huge single room. These astrophysical objects may be the densest stellar environments in the entire universe, he wrote. Whether that would even be physically possible is unclear. The other hypothesis proposes that this ludicrous density could be explained by a supermassive black hole at the center of the little red dots. Except the observation suggests that these would have to be overmassive or too big for what should be possible based on the scale of the surrounding galaxy, with some being nearly as heavy as them. Two-faced. This leads us to one of the little red dots' most puzzling attributes, according to Passucci. They appear like different objects depending on how you examine them. A vital indicator of the presence of supermassive black holes are telltale emission lines in light spectra. And when examined this way, the compact galaxies clearly appear to have them, if not be dominated by them. But if they contain supermassive black holes, the little red dots should also be blasting out X-rays. Most recent research, however, shown that the puzzling galaxies showing no sign of such X-rays, favoring the stars-only hypothesis. So black holes or no black holes, which is it? Passucci speculates that it's possible that the sheer density of material surrounding the little red dots, black holes, are blocking its X-ray emissions, or it could be that they are being emitted in a different spectrum than what we're used to. In any case, the implications are fascinating. We would be looking at unprecedentedly dense star-filled galaxies or evidence that overmassive black holes may have been the first ones in the universe. Anything is possible because we put our thoughts and it creates reality. So, observable, non-observable. My conclusion to a lot of the black hole stuff is that it's just a matrix that, just like here in our 3D, 4D space-time continuum, linear, there are portals that can jump you anywhere in space-time and time-space. I believe black holes are considerably very similar concept. I don't think they're these big giant things sucking in. We would already be sucked in a million times over if that was the case. If there's a large one at the middle of the galaxy, I mean, how many billions of years have we been here? And we're on the edge of our galaxy. We haven't shifted. Nothing has shifted. The Pleiades is still up there in the same spot. It just circles around us. The Orion belt for thousands and thousands of years. we're supposedly whizzing through time and space. Our Earth is supposed to be spinning in satanic numbers, and it doesn't make any fucking sense. Sorry, it just really doesn't. Water finds its level. I don't want to hear about gravity, it's density. It just, a lot of things just don't add up or make sense. And if we're spinning that fast, our days and nights would be in my estimation, would be, and I mean, it is going a lot quicker. So what the hell's up with that? No one's doing the math on that shit. All's perception. But in reality, think about it. When you're looking up at the night sky, if we are perpetually moving in actual space time, it doesn't matter for a globe or a toroidal field, doesn't matter. Okay, at some point, we should be seeing different constellations and different makeups of the zodiac, and yet we're still seeing Ursa Minor, Ursa Major. We're seeing Sirius, the star. We're seeing the Pleiades. We're seeing Orion. We're seeing the same shit that we see in the sky. It's just in different seasons. We see it at different aspect points. But we should already be like, where's Arcturus? Where's Boots? Where's the other constellations? Where are they? Why is it perpetually in the same? Just putting that one out there. It's kind of ruining paradigms, but if you think about it, if we are actually moving in the galaxy, we should be seeing different stars. I'm not saying you wouldn't still see those things, but we should, if we're moving as fast as they claim we are moving, we already should be seeing other constellations, other galaxies. We would already be eaten up by Andromeda by now, if this is the case, which it's not. So think about that, and then think about a telescope telling us about red tiny dots and supermassive black holes. We would already, maybe we are one. Just a lot of stuff doesn't add up. Just doesn't. Perception is bananas on this one. This next article is by PopularScience.com. In case of extinction, scientists store human genome on a memory crystal that lasts billions of years. The disk is as tough as quartz, withstands cosmic radiation, by Andrew Paul, posted on September 19th, 2024. Somewhere in that shelf, Radu Sinamar in Transylvania Sunrise and Moonrise talks about going into Bosegi Mountain in Romania, and something very similar pops up to tell you about that. All that fun. But like I said with the first article, even though it's ancient, I mean, how advanced is advanced? And then at what point is like extraterrestrial advancement already advanced? If they're moving up too in density, could you imagine the technology that they have? It's perplexing. It also has a Guinness World Record for the most durable digital storage medium. Researchers have encoded the entire human genome onto a 5D memory crystal. In the off chance our species finds itself needing to walk back from the brink of extinction. We've already been there, assholes. But even if the plan ultimately fails, the device itself is theoretically capable of providing our genetic code to some other future sentient third party, even if it takes them billions of years to find it. Whoever wrote this, hi Andrew. Hi. I hope you watch. Go ask Bashar, Daryl Anka, in his current self and the extraterrestrial that is him in a future self, what happens? Because we're hybridized. Hi. We're hybridized. And the ILO, there's another race. This is not new. Maybe the technology, but this is not new. We've been hybridized. Why do you think so many adults, children, get plucked from their houses and beamed on ships? Whether you perceive of that reality or not, like I said, we are advancing, we're ascending, we're moving up. So if it's a 3D human linear time continuum genomic code on a disk, great. But a lot of us are upgrading our innards. They're shifting, they're moving up. It's taking forever and it hurts and it sucks, but I'm shocked no one's really talking about that. Perplexing. For over a decade, the gold standard for the most durable data storage medium has been crystal. Well, there's obvious reasons for that. More specifically, a nanostructured glass disc developed in 2014 by a team of researchers led by optoelectronics professor, I'm totally butchering that, Peter Kaczynski at the University of Southampton. The 360 terabyte data crystal will remain suitable at room temperature for 300 quintillion years at a lifespan that only drops down to 13.8 billion years. The universe's current age, if heated to 374 degrees Fahrenheit, throw in ability to survive both high and low temperatures, direct impact forces up to 10 tons per square centimeter, as well as lengthy exposure to cosmic radiation. And it's easy to see how it is still the Guinness World Record holder for the most durable digital storage medium. Given the increased concern about today's often unreliable digital landscape, this also makes it one of the premier choices when safely archiving electronic information. Interesting. Knowing this, Kaczynski's group recently set to work encoding 3 billion character human genome into one of their coin-sized memory crystals. According to a university profile, Kaczynski and colleagues utilize ultra-fast lasers to etch the DNA code into voids within the disk silica as small as 20 nanometers wide. While most traditional information recording tools, such as paper and magnetic tape, are two-dimensional, the researchers encoded the crystal using 2 optical dimensions and 3 spatial coordinates to write throughout the material in what they describe as technically 5D. Taking inspiration from the Voyager mission's iconic golden records, the disk also includes a visual key explaining how to use it. There are also illustrations of male and female humans, the universal elements of hydrogen, oxygen, carbon, and nitrogen, DNA's molecular structure, and other potentially necessary information required for synthetically creating a person. Great! Hi, synthetics, clones. Speaking of which, Kaczynski's team is well aware that current technology is nowhere near advanced enough to do what their disk is intended to help archive. The said milestone is synthetic biology, such as the 2010 creation of synthetic bacterium, indicate a future with artificially created humans, as well as plants and animals may be possible. That is effing scary. We know from the work of others that genetic material of simple organisms can be synthesized and used in an existing cell to create a viable living specimen in a lab. Kaczynski said in a statement, the 5D memory crystal opens up possibilities for other researchers to build an everlasting repository of genomic information from which complex organisms like plants and animals might be restored should science in the future allow. For now, the human genome encoded 5D memory crystal is stored in the Memory of Mankind archive, a time capsule project located within the world's oldest salt mine in Hallstatt, Austria. If all goes as planned, it will remain until potentially needed, hopefully never. Wow. So technically, we're giving our future selves the ability to synthetically make humans, plants, and animals. They're already trying to tackle that crap now. That's scary. See, this is like a good thing because it's archiving things. Great, great. But we're giving it away. Here's where the negative intention comes in. We're giving it away at to what risk? So that if we wipe ourselves out, why should we wipe ourselves out? We can have the will and informed intention not to wipe ourselves out, to keep raising the frequency of the planet so that we ascend, that we don't have to worry about extinction in terms of what our program narrative tells us about wiping us off. So let's just be aired out here and now that I for it for preservation, but we already have our future selves already living, working, striving, helping, changing the paradigms all over the universe. Humans are already hybridized. The grays are an example. And we're just allowing for AI to get a nudge of that crystal, quantum entangled itself, and we can synthesize things in synthetic form. And that's very batshit crazy scary. Not a proponent of this at all. Just not. Nope. Glad it exists, but for the reason that it exists, I'm not crazy about. And it's already archived. The books tell you, and I totally align with those Transylvania Moonrise and Sunrise books. And I have to get to the other books that I bought with that. Tell me what you think. Yeah, the technology is great, but for the reasons that it is there for, it's kind of no, just no. We go from red dots, I don't believe in necessarily being there, in my paradigm at least, to insanity. This is going to like go back, double back on this black hole red dot thing. This is from Live Science. Stephen Hawking's black hole radiation paradox could finally be solved if black holes aren't what they seem. By Andrew Feldman, published September 20th, 2024. New research suggests that black holes may actually be frozen stars, bizarre quantum objects that lack a singularity and an event horizon, potentially solving some of the biggest paradoxes in black hole physics. Woo! A new study suggests that black holes may not be the featureless structureless entities that Einstein's general theory of relativity predicts them to be. Instead, the cosmic monsters might be bizarre quantum objects known as frozen stars. While these would share some similarities with black holes, the hypothetical celestial bodies differ in crucial ways that could potentially resolve the infamous Hawking radiation paradox, named for the late physicist Stephen Hawking, who proposed the phenomenon. This paradox arises because the theoretical radiation emitted by a black hole's event horizon seemingly carries no information about the matter that formed the black hole, which contradicts a fundamental principle of quantum mechanics, stating that information cannot be destroyed. Absolute fucking truth. Moreover, unlike the conventional black holes, frozen stars are not expected to harbor singularity, a point of infinite density at their centers, which resolves another contradiction between the classical picture of black holes and the general rule in physics that infinities cannot exist in nature. When infinities do appear in a theory, it usually signals the theory's limitations. Frozen stars are a type of black hole mimickers, ultracomposite astrophysical objects that are free of singularities, lack a horizon, but yet can mimic all of the observable properties of black holes. Ramses Brunstein, a professor of physics at Ben Gurion University in Israel, told Live Science in an email, if they actually exist, they would indicate the need to modify in a significant and fundamental way Einstein's theory of general relativity. Brunstein is a co-author of a study describing the frozen star theory published in July in the Journal of Physics Review. Resolving the paradox. The classical model of a black hole, first described by Carl Schwarzschild in 1916, portrays black holes as having two key features: a singularity where all the mass is concentrated, and the event horizon, a boundary from which nothing, not even light, can escape. However, the model encounters a serious problem when quantum mechanics is introduced. In the 1970s, Stephen Hawking famously discovered the quantum effects near the event horizon should lead to the creation of particles out of the vacuum of space, a process known as Hawking radiation. This radiation would cause the black hole to gradually lose mass and eventually evaporate completely. The paradox arises because the radiation appears to carry no information about the matter that originally formed the black hole. If the black hole evaporates completely, this information seems to be lost forever, violating the principles of quantum mechanics, which dictate that information must be conserved. This contradiction is known as the information loss paradox, and it has been one of the most significant challenges in theoretical physics. In the new study, Brunstein and fellow co-author I want to say that's J.M. of Rhodes University, and Tara Simon of Ben Gurion University performed a detailed theoretical analysis of the frozen stars model and found that it resolves the paradoxes of the traditional model because it lacks both a horizon and a singularity. The authors found that if black holes are actually very compact objects composed of ultra-rigid matter, whose properties are inspired by string theory, the leading candidate for the theory of quantum gravity, they do not collapse into infinity-dense points and have a size slightly larger than the conventional event horizon, preventing the latter from forming. We have shown how frozen stars behave as nearly perfect absorbers, although lacking a horizon, and act as a source of gravitational waves, said Bernstein, noting that these objects can absorb almost everything that falls in onto them, much like black holes. Moreover, they source the same external geometry as that of conventional model of black holes and reproduce their conventional thermodynamic properties. While the frozen star model presents a potential solution to the paradoxes associated with traditional black holes, scientists still need to test it experimentally. But unlike conventional black holes, frozen stars are expected to have an internal structure, albeit one with bizarre properties dictated by quantum gravity. This paves the way to observationally discriminate between the two. The evidence could be present in gravitational waves, ripples in the fabric of space-time generated by black hole mergers. This is when the distinctions would be most pronounced. The team still needs to work out exactly what the internal structure of frozen stars would look like and how it would differ from other extreme cosmic objects like neutron stars, but it's achievable, Bernstein said. From there, they could analyze data from existing and future gravitational wave observatories because the gravitational waves emitted during the mergers are extremely powerful and can carry information about these ultra-compact object structures. That is a paradox, a good one. Once again, we are finding that we are now discovering the higher states of what we're all shedding light on now. We are plucking from the ether. We're playing catch up with all this high-tech information that's already up here, but now it's like, yay, we got it. Woohoo! And the old paradigm is going bye-bye. Bye. So there's a lot of what was to what is now in the current time structure that is being challenged. And we're going to keep seeing a lot of this challenge as quantum science elevates, which is great. But regardless of any of those factoids, I'm not a big a proponent of black holes. I believe it's a matrix system with wormholes and things that we can't even comprehend because we're not there in the cognizance of it yet to comprehend it. I believe there's a lot more definition that we have yet to even come into a realization about, and we're only on the cusp of such bigger and larger things. Understanding and what density and dimension is this happening in? That's what I like to ask and propose to physicists, because if we're now on 4D and we're still in a 3D mindset, what are the bigger concepts that we're missing? Because we're still, a lot of people are not aware that they already shifted into 4D, which is bound by different types of mathematics. Ontological is a bridge to the higher, and what mathematical formulas and physics formulas that are going to hold in 5 if we become more luminescent, that the game changes. Electricity and all those things are components that are still, they're defined in a 3D sense, but they're not redefined into a higher aspect. And that's what we're watching right now, spiritually happening, trying to still merge the spirituality and metaphysics. Sorry, guys, my back is killing me today. Not a good day at work. As we could see, my hair is like a shit show. Um, we are merging, and like I keep saying on my TikToks, your definition over here that is so vastly infinite with a million different possibilities of defining something, like the word love, is perceived and felt differently by every human being. There's similarities and commonalities, but the actual feeling itself is only felt by the individual. So, this stupid camera. When we're looking at these large scale concepts, whether they be real or not, we're taking a very vast, simplistic idea of what something is, and we're defining it now higher up here. So we're seeing physics, mathematics, chemistry, all the realms of science actually shifting and going higher. We're seeing this before our very eyes, and that's why I love doing these and reading some of these articles. They pique my interest because of not just the caption, the nuts and the bolts that are in there to put the bigger picture together, if that makes sense. Last article of the night from physics.org. Is quantized, RedShift, quantized, don't know what that is. RedShift and challenges to Big Bang hypothesis. This is by Arindam Mal, Roy. The colors of the font are super light, so I do apologize. A Doppler shift is defined as a change of frequency of light or sound when an object is moving toward or away from an observer. Edwin Hubble observed in 1929 that galaxies appear on average to be moving away from us. See figure above, and it's just showing waves. Which could indicate that the universe is expanding, an effect that became known as the Hubble law. An increase in the wavelength of light due to an object moving away manifests as a shift toward the red end of the optical spectrum and is therefore referred to by astronomers as a red shift. In standard cosmology, due directly to the Hubble law, redshift is also assumed to be a distant indicator. Recent precision measurements of the cosmic microwave background is explained by the standard model as the oldest light of the universe, and another method, brightest star standard candle, to support the idea that expansion of the universe is faster than what astronomers originally expected, based on standard model understanding of initial conditions and subsequent evolution of the universe. Many aspects of the evolution are not fully understood. This includes the actual view of the Hubble parameter, and since this presumed constant is fundamental to standard cosmology, the prolific and continuing argument about its value is referred to ephemerically by its proponents as the Hubble tension. On the other hand, alternative cosmologies are free of the unnecessary and self-imposing conundrum. Odin shifted his location. Quantized redshift. Alternative scientists do not agree with the concept of expansion of the universe, in part due to the multiple findings that extragalactic objects exhibit redshift periodically. Also, periodicity, sorry guys, also known as redshift quantization, which is characterized by the tendency of distant objects, in particular galaxies and quasars, to cluster around linear or logarithmic multiples of some particular redshift value. In standard inflationary cosmological models, the redshift of cosmological bodies is ascribed to the expansion of the universe, with greater redshift indicating greater cosmic distance from the Earth, Hubble's law, and referred to as cosmological redshift. Quantized redshift of cosmological objects would either indicate that they are physically arranged in a quantized pattern, or that there is an unknown mechanism for redshift that is not related to cosmic expansion and is instead referred as intrinsic or non-cosmological. William G. Tift observed periodically in galaxy redshifts, and according to Halton, Arp, and Jeffrey Burbridge, redshift disparities in quasars are due to the intrinsic component that is inherent to an evolutionary process. Since 1966, some scientists have claimed that redshift is not only due to Doppler shift. Hoyle and Norliker, 1966, observed an apparent physical association of quasars and galaxies, but with different redshifts, as exemplified by a quasar with Z equals 2.114, very close to the nucleus of the galaxy NGC 7319, with Z equals 0.022. As noted in our paper published in Research in Astronomy and Astrophysics, Halton Arp observed many such pair cases. There is, geez Louise, there is a notable case directly observed by Lopez Cord something. Sorry, I'm gonna butcher that and I can't get it out. Gutierrez, 2004, with two quasars resting on a filament that connects two galaxies. All four objects have different redshifts from one another. Give me a second, guys. I'm going to cough my brains out. I don't need that again. Okay, after that coughing fit, I do apologize. On the other hand, standard cosmology uses gravitational lensing to explain the apparent physical association of quasar-galaxy pairs, a phenomenon in which light from a background object is bent due to the gravity of an intervening foreground object with very large mass. I'm skipping around a little bit. Physics of quantized redshift. The Hoyle-Narlark variable mass hypothesis provides a framework in which quasars are ejected from galactic nuclei, starting with low mass and high redshift, extracting energy from the surrounding system, and over time increasing in mass and decreasing in redshift, with redshift being related to mass rather than distance. Dynamic multiple scattering is another theory that may explain redshifts dependent of environmental characteristics. In laboratory conditions, redshift has been observed between two stationary objects where no Doppler shift is expected due to characteristics of the media in which the experiments were performed. In conclusion, in this paper, we have used a singular value decomposition-based method for data analysis. We have described in our previous paper that SVD is robust in comparison to the standard method of using periogram to perform periodicity estimation in noisy or quasar periodic data sets. Concerning recent observations about extragalactic redshifts, alternative cosmology confirms its predictions in cases that otherwise produce discrepancies when the presets of standard cosmology are applied. It is necessary to have observational evidence to validate any model. So the observational data like redshift, periodicity of a galaxy quasar pair gives rise to a new challenge in observational astronomy for extragalactic objects and Big Bang hypotheses. And I'm going to end it there. Fun. All of this is a very interesting compendium of articles that I have found very interesting. And I always peg the question, density and dimensional space. Which one is it? Because our thoughts create things, we have created the Big Bang. When God said, let there be light, and boom, all the elements and everything started forming. Yeah, that I don't think can be calculable because it happened in a higher dimensional frequency state of existence that we can't even to this day comprehend in this form. So, yeah, as much as we want to answer the questions of the universe, they're never going to be answered. And they're not. Sorry. And even higher density beings have like still the questions of questions. They just have a better way of just understanding, and they're not going to give us all the shit. That would be imposing on free will. Because then we wouldn't be exploring and knowing what we prefer over what we don't prefer. So it's an interesting concept. All these articles are very interesting, but it's showing us how we are expanding our thinking, how we are expanding the mathematics, we're expanding the concepts, we're theorizing and expanding on the theories of old, making them new and adding on to them, or saying, this doesn't even apply anymore. We now have a better understanding of things via this method or this theory or this person, and boink, textbooks I don't think they'll be rewritten. I'll just think new ones will be written, and the old ones can be left to the archive and maybe stored on a crystal. Who knows? So guys, I hope you enjoyed this insanity of me coughing and butchering names. Quantum AI and metaphysical ponderings. Let me know what you think. Once again, we need to be aware of what is going on in our universities, these labs, these laboratories around the world. It's just not in the United States, it's everywhere. And we are still allowing a lot of things to happen. And yes, there are experiments, but some consequences to experiments can shift our paradigm. I mean, we're having a new fucking moon come into the gravitational pull, which I don't believe is gravitational, and maybe it's another heavenly body, or maybe it's just an illusion of the holographic simulated matrix that, once again, everything is having you question your reality. And why not let this question help normal people question their paradigms? I don't know. Doesn't bother me or affect me in any such manner. So have fun with that. Keep digging. So guys, sending each and every one of you love like a passion, grace, shielding, and protective energy. Please go within. Be the shoulder for somebody. Be the lighthouse, seed your truths, and I hope to see you guys on the next one. Please check out my website. The holidays are coming. I hopefully will be able to pay my bills and find a second job, which I'm looking to do right now. So I thank you all for your help, your awesomeness, Amish mindset, and I hope to see you guys on the next one. Have a great and fantastic rest of your week. Bye for now.